Accuracy is a crucial concept in the field of machine learning, which refers to the degree of correctness of a model's predictions. Essentially, accuracy measures how well a machine learning model can classify new data points based on its training data. In the context of machine learning, accuracy is important because it is used to evaluate the effectiveness of a model. In particular, it is used to determine how well a model can generalize to new data points that it has not seen before. If a model has high accuracy, it can be considered reliable and effective in making predictions. Accuracy in machine learning is a metric used to measure how often a model correctly predicts the outcome of a particular classification problem. In other words, it is a measure of how well the model is able to distinguish between different classes of data. The formula for calculating accuracy is simple. It is the ratio of the number of correct predictions made by the model to the total number of predictions made. Mathematically, it can be expressed as follows. Accuracy equals the number of correct predictions divided by the total number of predictions times 100%. Consider the following example. Suppose we have a binary classification problem where we want to predict whether an email is spam or not. We have a dataset of 100 emails, of which 60 are spam and 40 are not. We train a model on this data and use it to predict the class labels of 20 new emails. The model predicts 12 of these emails as spam and 8 as not spam. To calculate accuracy, we first need to determine the number of correct predictions made by the model. In this case, the model correctly predicted 10 of the spam emails and 8 of the non-spam emails for a total of 18 correct predictions. Therefore, the accuracy of the model is accuracy equals 18 divided by 20 times 100 equals 90%. This means that the model was able to correctly predict the outcome of 90% of the new emails it was given. While accuracy is a useful metric for evaluating the performance of a model, it should be used in conjunction with other metrics, especially in cases where the data is imbalanced or the cost of making incorrect predictions is high. In such cases, metrics like precision, recall, and F1 score may provide a more comprehensive view of a model's performance. Let's have a look at some real-world examples. In image classification, accuracy would be used to measure how often a model correctly identifies the species of an animal in an image. Sentiment analysis uses accuracy to measure how often a model correctly identifies the sentiment of a customer review. In each case, accuracy is a critical measure of the reliability and effectiveness of the model. In addition to these applications, accuracy is also used in fraud detection, medical diagnosis, and autonomous vehicles. In fraud detection, machine learning models are used to identify fraudulent transactions in financial data, and accuracy is used to measure how often the model correctly identifies a fraudulent transaction. In medical diagnosis, machine learning models are trained to identify signs of disease in medical images or patient data, and accuracy is used to measure how often the model correctly identifies a disease or condition. Accuracy is a commonly used performance metric in machine learning that measures the overall correctness of a model's predictions. It is a useful metric in many applications, but it has several limitations that must be taken into account. One such limitation is the impact of imbalanced datasets, where one class is much more common than others. In such cases, a model that always predicts the majority class can achieve high accuracy, even if it performs poorly on the minority classes. The trade-offs between precision and recall also need to be considered, as high precision means the model is unlikely to make false positive predictions, while high recall means the model is unlikely to miss positive cases. Additionally, the impact of false positives and false negatives needs to be carefully considered, as the cost of incorrect predictions can vary depending on the specific application. Overall, while accuracy is a useful performance metric, it is important to understand its limitations and to carefully consider the appropriate performance metrics for each individual machine learning project. If you have any questions or comments about this video, please feel free to leave them in the comments section below. And don't forget to subscribe to our channel for more informative videos on machine learning and related topics. Thank you for watching, and we look forward to seeing you in our next video.